Okay, guys, today we got parameters for binomial distributions. Worked on binomial distributions yesterday and gonna build on it a little bit today. All right, basically what parameters are is gonna be statistics on binomial distributions. So we're gonna work on the mean today, the variance, mainly the mean and standard deviation because that tells us the most. Those that we're gonna try to find the most, but we're also gonna really use those to interpret and understand what those things represent. Like what's the mean telling you? What does the standard deviation tell you? And also are things unusually high or low? So here's what you need for sure, the binomial distribution formulas. The mean of a binomial distribution, you just do the mu is n times p. And don't forget what n means. Oh, it tells you down at the bottom. N is how many trials there are. P, probability of success, and Q, remember, probability of failure. So the mean, we're just going to do n times p. That's going to be the mean, or also known as the expected value. Variance is n times p times q. And this is the one that's probably most important, more important than the variance anyway. Standard deviation is the square root of the variance, or the square root of n times p times q. That's the one we're going to use the most. All right, how are we going to interpret these things? Same way we always have been. We're going to use the range rule of thumb, which means most of the values, well, the usual values will lie within 2 standard deviations away from your mean, or your mu. So the maximum usual is going to be the mu plus 2 times the standard deviation. The minimum is going to be the mu minus 2 times the standard deviation. And that's how we're going to tell if something is usual or unusual based on the range rule of thumb. All right, let's try one here. It says McDonald's has a 95% recognition rate. A special focus group consists of 12 randomly selected adults, meaning if you say the word McDonald's, 95% people know what that is. For such a group, first of all, let's find the mean and standard deviation. So there's 12 people. That's how many trials there were. You have a 95% success rate, so 0.95, and you get 11.4. You would expect if you ask 12 people if they know what McDonald's is, 11.4 would know. Standard deviation, square root of n times p times q. There those are. Don't forget q is 0.05 because p and q always add up to be 1. Got that decimal right there. I'm going to round it up to 0.8, so it's not quite so big. All right, so using the range rule of thumb, find the minimum maximum number of people who would recognize McDonald's. So I took the mu, added 2 times standard deviation, I got 13, which means out of 12 people, there's no way to get a high unusual number. Did the same thing with minus 2 times standard deviation, got 9.8. So anything under 9.8 people would be unusual in a sample. If you pick just 12 people, if you got less than 9 or literally less than 10 people, then that would be unusual for them not to know what McDonald's is, which is crazy. That's a lot. That means almost everybody knows what McDonald's is, which is not surprising. All right, one more example here. The chapter problem includes results from the XSort method of gender selection among 945, that's our n, that's our sample size, 879 were girls using XSort. Okay, part A, assuming that boys and girls are equally likely, find the mean and standard deviation for a number of girls. Okay, it is binomial because it's either boy or girl, 2 outcomes, and there's a fixed number of events. So part A, I just did the same thing. I did n times p, so I would expect 472.5 girls. Also found the standard deviation square root of npq and got 15.4. So part B says use the range rule of thumb to find the minimum and maximum of the usual, or equally, if they're equally likely. So part B, I did that, mu minus 2 times standard deviation, worked it out, got 441.7. For the max, I did the mu plus 2 times standard deviation, worked that out, got 503.3. So the usual numbers you would expect of girls would be between those two, because that really 95% of girls should fall in there. 95% of babies should be girls. Never mind. You would expect in 95% of samples that the number of girls would fall in between those two. How about that? That's the way I should have said it. And then part C, the last thing says, is 879 girls unusually high? And because 879 is way outside of 503.3, it is definitely unusually high, which means we would not expect that to happen just by chance, like, oh, it accidentally happened. No, that's way too high for that to happen by chance. So we would conclude that we would say this. The conclusion would be that it appears that this method is effective. We can't prove that's effective just by looking at the numbers, but we can say it sure does look like it statistically that it is effective because it's too big of a number to happen just by chance. And what I just said, that sentence, couple of paragraphs right there, is exactly where we're heading in statistics the rest of the year. Trying to figure out if something just kind of happened by chance or if it's, statistically significant. So hope that makes some sense today. Pretty short video. We'll work on it in class tomorrow like we always do. See you then.